Third type of bonding that we're going to talk about is covalent bonding. This is very much different than ionic and metallic as we've discussed earlier. The whole purpose behind it is to take something as unstable here as a single atom of hydrogen and make it more stable by filling up its outer electron shell, the valence shell, by sharing of valence electrons. So as we define covalent bond, a covalent bond is going to be the sharing of valence electrons. And the whole purpose behind any type of bonding, but especially covalent bonding, is to reduce the amount of energy. So you become more stable when you're using less energy, according to the atom. So less energy equals increased stability. The picture down below points out several different very common molecules that feature covalent bonding. The term that we would use for any individual piece here is called a molecule. So when we talked about ionic bonding, we were talking about formula units. When we're talking about covalent bonding, the representative unit is going to be a molecule. Also, when we're dealing with molecules, typically we're talking about nonmetals bonding with other nonmetals. So if you look here at any one of these molecules here, one thing is very common. They're all missing one very, very important thing to the other type of bonding that we've talked about, and that's metals. There are no metals typically when we're talking about covalent bonding. When we talk about the different types of covalent bonding, we're talking about the number of bonds that are formed. And we're also talking about, more specifically within that, the amount of shared electrons. This first picture up here features two different atoms of fluorine. We know it's fluorine by the number of total electrons present with each atom. Notice an overlapping here in the middle. Between the two atoms, there is one pair of shared electrons. One pair of shared electrons equals one bonding pair equals a single bond. The top picture over here at the right is another example of a single bond. The difference, however, between that one and the one below it is that we have two pairs of electrons shared between them here. So if you think about the atoms as being the circles of a Venn diagram, we have a lot of information stored between them. They're being shared. So because we're talking about two pairs of shared electrons, we're talking about two bonding pairs, we're talking about a double bond. The third diagram down here at the lower left features nitrogen. Notice in the middle, that shared set, we are dealing with 6 total electrons. Well, 6 total electrons is 3 pairs. That's 3 bonding pairs. And that's something we call a triple bond. And no, before you think it, there's no such thing as a quadruple bond. It doesn't work that way. The last thing we're going to look at is just how many likely bonds are going to happen. Now remember, everyone's trying to achieve that stable number again. And that stable number is 8 in that octet that we talked about before. So if we're talking about nonmetals, typically we're talking about that right side of the periodic table, or the P block area. Now within that area we have 4 primary groups: 7A, 6A, 5A, and 4A. Elements in group 7A, as is the example over here at the left side, tend to form one covalent bond because they contain 7 valence electrons and they want to get to a stable number 8. Therefore, they will each look to form one covalent bond to share one set of electrons to get to their number. Oxygen, however, in group 6A, along with sulfur and selenium and a few of the other elements, will form covalent bonds to get to their 8. Now, because they have 6 valence electrons, they will form 2 covalent bonds. Not necessarily always with each other, but they will always form 2 covalent bonds. Nitrogen, as we mentioned before, contains 5 valence electrons. 5 valence electrons means that they will share 3 sets of electrons or will form 3 covalent bonds. This last example over on the right side features carbon. Carbon contains 4 valence electrons, and we ignored carbon when we were talking about ionic bonding for good reason. It's no easier to gain or to lose 4 valence electrons and form a charge. So carbon does not ionically bond. Instead, carbon is one of the most important elements for covalent bonding. Because it has 4 valence electrons, carbon will form 4 total covalent bonds, whether it be with the same element or different elements. We're going to talk a lot more in class about how to form these structures. They're called Lewis structures. We'll be dealing with that in class over the next couple videos.